I should have done problem number 7 on that same video. I just realized it. So let me go ahead and do number 7 as well. And then we'll start the video, what I really wanted to show on this next video. But let me go ahead and do this one. I meant to show number 7 when I did the first 6, because that one was also those same 3 questions. Draw it in standard position, find a coterminal angle within one rotation, and then find the reference angle. So for 510 degrees, okay, what you should be thinking about is how all the way around is 360. So go ahead and subtract that off. And you have 150 degrees left. So that means that would be 90 and then 60 more, okay, be like right about there. Okay, well, this right here, those are coterminal with the 150 being within one rotation. So it's like you subtract off that extra twirl, okay? All right, and then, so that's the standard position drawn. This is the coterminal angle right here. And then it wanted the reference angle. So the reference angle, I'll do that one in red, would be this angle. It would be how many degrees that is, the difference between the terminal side and the x-axis. And if this is 150 and this is 180, you're 30 degrees away, aren't you? Okay, so 30 degrees is the reference angle. All right, and the idea I really, really, really hope you get is that if you do, say, the sine of, let me do cosine because it'll be more interesting. If you do the cosine of 510, that's going to equal the cosine of 150 exactly. Same everything, okay? But if you did the cosine of 510 and you tried to use the cosine of 30, okay, 30, the cosine of 30 and the cosine of 510 are going to be the same number part. And we know the cosine of 30 because we know these 30, 60, 90 triangles, right? So the cosine of 30 would be square root of 3 over 2. So we know that the cosine of 510 or the cosine of 150 even would equal the cosine of 150. And that's going to equal the cosine of 30, except I have to think about my original angle is in the second quadrant and the cosine's negative. So I'll have to throw a negative on that. So that'll be negative square root of 3 over 2. So that's kind of the idea. See, the coterminal angles will be the same exact value, okay? And then the reference angle, it will be the same except for the sign. You might need to add a negative on it, depending upon the quadrant you're in. It's a big idea. It's kind of one of the major points from 5.1 to 5.4, and I really expect you to make sense of that and to use it when it's appropriate, okay? All right, now let's continue. That's where I should have included that on the last video. So this video is supposed to be looking at the basics. Okay, so I'm going to do this horizontally. So number 8 gave you a triangle, and I can't really see those measurements very well. Okay, I had a right triangle. Here was the theta. And this was 6, it looks like. I'm going to open up the textbook, make sure I'm not using the correct numbers. The other one's blurry. This is 598 out of the textbook. All right. All right, so this is the mid-chapter checkpoint. Yeah, so this is 5 over here. I couldn't read that number on my problem. You may not be able to either. Okay, so that's number 8. So number 8's using a right triangle. Number 9, and it wants the 6 trig functions of theta. Find the 6 trig functions. 6 trig functions of theta. Okay, number 9 wants the 6 trig functions of theta. And what it does is it gives you theta, and it shows you that it's here. And it gives you this point, 3, -2. to the terminal side, and it says this is your theta, and it wants you to find the 6 trig functions of theta, given this point 3, -2 is on the terminal side. So still find the 6 trig functions, just a slightly different thing. And then problem number 10 says you got a point on the unit circle and you want the 6 trig functions at t. Okay, so what's going on there? You got a unit circle, okay, and they tell you that you're over here and that the coordinates are -3/5, -4/5. And the way they draw it's a little misleading. I kind of want you to understand t a little differently. So t would be actually the length of this arc right here. So, you know, if we did draw the angle, think of t as being the length of that arc. So it's really the radian measure of that angle. The radian measure of an angle on a unit circle and the length of the arc intercepted wind up being the same. And so then they want you to do the 6 trig functions. This time it would be the 6 trig functions of t. Okay. All right. So I know my writing's not the best. I use the screen kind of upright, so it's a little awkward, but I need it that way. Okay. So we're going to do sine, cosine, tangent on all of these. And then we're going to come back and we're going to do cosecant, secant, and cotangent. That's what they mean when they say the 6 trig functions. So here, that'll be theta. Here, it'll be theta. Oops, cotangent. And here it's really the same concept, but just a t. And that kind of takes you through what was going on in 5.1 to 5.4. You started with trig functions of only angles that could be in a right triangle. Then you talked about angles that could be really not necessarily acute. They could be even more than 360 sometimes. Okay. And then you looked at angles in a unit circle, and from there said, well, if you're talking about the angle in radians, you're really looking at the trig values of a length, you know, basically the trig functions of a number. And so it kind of transitions you to use the same idea, but in slightly different contexts. Okay, so now we're looking at the trig function of a real number, but it's all basically the same type of definitions. So with number 8, that was the one where you thought SOHCAHTOA. Okay, and theta's here, so it helped to understand that this would be the adjacent side. This would be opposite theta, and this would be the hypotenuse. And the orientation of the triangle matters, so you have to really get used to paying attention to where you're located. All right, so sine would be 5/6. We can do that without any additional work. But for cosine, I need the adjacent side. So that's when I'm going to be thinking 5 squared plus something squared equals 6 squared. It's an equal sign right there. So then 25 plus x squared is 36. So x squared would be 11, wouldn't it, when you subtract 25? And so that means x, this side right here, would be the square root of 11. Okay, that's that side. So cosine would be square root of 11/6. And then tangent would be 5 opposite over adjacent, but I'd have to rationalize. So I'll get 5 square root of 11/11. Cosecant, I'm actually going to compare to sine and flip over the sine value. Okay, now it is true that cosecant is hypotenuse over opposite, but I like to just think about cosecant being the reciprocal of the sine value. Secant goes with cosine, so you could flip that over, but then you got to rationalize. So you get 6 square root of 11/11. And then cotangent is going to be the reciprocal of tangent, and this would be the best spot to look at because when you flip that over, you don't have to do any additional work. And so that would be your cotangent, and you're done. Okay. Now, what happens when we kind of expand our thinking to be angles that aren't just stuck within a right triangle is we can imagine dropping a perpendicular to the x-axis. All right. And this is 3, the point 3, -2. So think of that, this segment, even though the length of it's 2, because I had to go down to get to this point, keep the negative on it, and then you'll have the values, the proper SIGN on your sine, cosine, and tangent values. All right, you are going to need the hypotenuse, so you might as well get that out of the way. So that'd be 3 squared plus -2 squared. So that's 9 plus 4, which is 13. And then I'm going to come in here and think about that being not 13, it'd be square root of 13. Okay, right, square root of 13. And then I'm going to come in here and do all of these. So this would be -2 over the square root of 13. I'll have to go back and rationalize it. And see, even though this is what I'm looking at, pay attention to that reference angle. But if you put the negative on the 2, then when you do the cosine and the sine, you'll have the correct value for those. So the cosine of theta should be 3 over the square root of 13. I'll go back and rationalize it. Tangent would be -2 over 3. Cosecant, that would be the reciprocal of sine. So it would be negative square root of 13 over 2. Secant, the reciprocal of cosine. And then cotangent would be the reciprocal of tangent. Okay. And then you're going to need to have rationalized. So I don't want to give you a bad habit. And so then that was already good. Didn't need to do anything there. So those are the values that I would get. Okay. All right. And then on this one, we're on a unit circle. So here, see, the radius was square root of 13. So if we had a circle on here, let me draw it in black, we would not have been on a unit circle, right? The circle would have been something like that. Okay. Sorry, so bad. So we weren't on a unit circle. Okay. Now we're on a unit circle. This is 1 unit. So when we do sine here, okay, the x coordinate is your cosine value and the y coordinate is the sine of t. Okay. All right. So sine of t should be like y over r typically, but your y is -4/5 and your r is 1. I'll just do it on that one. So see how it just turns out to be -4/5. So if you're on a unit circle, the points on the unit circle are actually your cosine followed by your sine. So that means this would be -3/5. And then tangent we know is sine over cosine. So that means it's going to be -4/5 over -3/5. And that's a complex fraction that I need to simplify. Negative divided by a negative is positive. Multiply by the least common denominator, and you wind up with just 4/3. Okay, cosecant goes with sine, so I'm going to flip over that, get a -5/4. Secant goes with cosine, flip over that, I'm going to get a -5/3. And see how we're in the third quadrant, so both sine and cosine are negative, okay? But then tangent, since it's sine divided by cosine, turns out to be positive, and so does cotangent, okay? So 8, 9, and 10 kind of give you the like progression of ideas in 5-1 to 5-4. Here we are in a right triangle. Here we are considering sine, cosine, and tangent in a circle. Here we are in a circle, but the radius is 1. And we transition from any angle to over here being able to think about just the sine, cosine, and tangent of a real number. All right, better stop because I got dinner cooking and I'm about to burn it. So let me stop here and I'll do another video that continues from there.